Hi guys, welcome to the first video of the Arduino Robotics workshop series with IgniterSpace. So hope you all are enjoying your time at home and spending it productively. I apologize for the issue that we had with the live streaming software. As you all know, this is the first time we tried to do it, and since a lot of you were very enthusiastic in joining the program, we had over 100 participants trying to join the software at the same time. So unfortunately the software couldn't handle it and it crashed. We are very sorry about the inconvenience. Therefore, just for today, please accept this pre-recorded video where I will show you what Arduino can do, and we will make a very fun project with it. So let's go ahead and dig right in. Alright, so for this lesson, we are going to learn about what Arduino is and what the benefits of Arduino is when it comes to creating robotic projects. So the importance is today you do not need to have an Arduino with you, because I'll be showing you how to use an online circuit simulation software to create any Arduino project. So that's going to be very fun, because this software has all the required sensors and components, different electronic components that is required for you to do any sort of electronic project. So I will introduce you to that platform today, and we will also learn how to code using Arduino. So even if you have done it before, if some of those parts are unclear to you, if you really don't understand the steps, this is the best way for you to understand and learn those in detail. So today we are going to be solving a real world problem using Arduino. Now you know that we live in Sri Lanka, and we have quite a lot of traffic here, right? Not these days because it's curfew and nobody's allowed to go to the roads. We don't have anyone in the roads, but on a general day, we have so many people who is trying to travel from one place to another in our roads. So we have traffic lights like this in different parts of the country, in different parts of the road, especially in junctions, to control the flow of traffic. Now we see policemen just like this are finding it very hard sometimes to control the traffic. This photo that was taken, I think, in Colombo, I think this is the Miracoda Junction. You can see these two gentlemen here are trying to control this traffic. This three-wheeler is trying to go this side, there's a bus waiting over the other side, and the whole thing looks like a big mess. So as you can see, and as you know, the normal traffic lights can be inefficient in controlling heavy traffic. So as I said before, we are going to be learning how to create a traffic light, automated traffic light using Arduino, and this traffic light we can also control it using a push button. It's a very simple program, but we are going to learn the different parts of Arduino and how we are going to upload a code to Arduino, and most importantly we learn about that new circuit simulation platform. So you all know what Arduino is. For those who do not know what Arduino is a combination of a hardware and a software platform. So simply saying, Arduino is like a small microcontroller chip, like a small computer if you want to think so. So it has different components that allow us to input and output electric signals, and using Arduino we can make really fun robotic projects. So Arduino was first developed and designed in Italy, and most of you have must be already owning one of these Arduino boards. So Arduino, as I said, is a combination of both hardware and software, and using this Arduino software, or we call it Sketch, we can code different programs and we can upload it to the Arduino. And the Arduino as a hardware has different we can input the different electronic signals using different sensors like light sensors, motion sensors, position sensors, and of course we can output electric signals and make the world see that, or make us see that, through lighting up LEDs, moving wheels, through motors and things like that. So there are various types of Arduino boards. So this Arduino is one type of microcontroller. There are many other types of microcontrollers and small computers like the Raspberry Pi, the Node MCU. So just for you to find out a little bit more about that, go online and search about different types of microcontrollers. But Arduino is one of these types, and it is the world's most popular type and the best for learning about robotics. So there are different, as you can see, different shapes and sizes of Arduino boards that are available commercially. So we are using the Arduino Uno, which is the best board to start off or start off with your Arduino journey. Then we have a slightly different version, a newer version, which is the Arduino Leonardo. I believe this has Wi-Fi connectivity as well. The Uno doesn't. Then we have the Arduino Mega. It's a bigger version of the Arduino Uno. This has more input and output pins. So if you are doing a project with a lot of sensors, a lot of components, the Mega is a good board, and it has a slightly higher processing power as well. The Arduino Lily Pad is an interesting board. It is a very beautiful shape, like a small circle, like a lily actually. It is used in places where you can easily conceal the microcontroller. For example, if you're making some kind of smart fabric or a cap or something like that, a wearable device, Lily is quite useful. The Mini and the Arduino Nano are very small boards. They do not have direct input pins like this. You have to fix it to the breadboard, or you have to solder the electronic components. So this is also good if you are starting out, or it's also good with very tiny projects. But again, the Uno is the best type of board for our particular purpose. So let's see what are the different parts of an Arduino Uno. So the main part is of course the USB port, or some of these have the power connector. Both of these we use these two to enter or insert power to the Arduino. So we power the Arduino board using these two particular ports. So you can connect this USB port to your computer USB and easily give the 5 volts of power required for this Arduino to work. And once you upload a code, so you upload the code also using this USB port, and clicking the reset button, you can make the code start from the beginning, which you must have already done. Then this side we have our digital inputs and outputs. So you know there are two types of electric signals. We have digital signals and we have analog signals. Digital signals are high or low, 1 or 0. Analog signals can vary up and down, digital is only up, 1 or 0. So these are the difference between analog and digital, if you don't know. So these pins, using these pins, you can input and output digital electronic signals, and using these pins, the analog pins, you can input and output analog electronic signals. There is a power LED and an on-board LED, and you have the chip, the microcontroller chip. In the Arduino Uno we call it the Atmega chip. So these are the main parts. There are no onboard sensors in an Arduino Uno like the microbit. If you know about the microbit has few onboard sensors within them, but the Arduino Uno doesn't. So you need to plug the different sensors like an ultrasonic sensor or whatever it is. Just talking about the various components, here we are. So you can see there are many different sensors that we can use with Arduino. In the course at IgniterSpace, we will only be covering few. For example, the ultrasonic sensor and so forth. But you can really find out online how you can work with these sensors, because they are very easy to use and they are very cheap to buy. So you can easily find them. For example, using the raindrop sensor, we can build a small alarm that works when it rains. Using the soil moisture sensor, you can create auto watering plant. Then using things like the tilt sensor, you can measure the different tilt angles. The smoke sensor, you can build a gas detector for a room, right? Flame sensor to detect the heat. So there's quite a lot of different kind of sensors and different actuators. Actuators are things that produce output, like the motor, servo motor. For example, if you are building a robo arm, then there are if you can't see over here, it's hidden, but you have this different display components like this. We call it the 7-segment display. This is the LCD display, liquid crystal display. So you can display signals, and generally we use a breadboard to connect these electronic components together when we are building it. So these are some of the various Arduino components that are available. And these are and you can do many things with this. So we code in an Arduino using a programming language called the C programming language. Now C is one of the oldest and most basic programming languages. It is the essence, or it is the main part in many of the programming languages that we use today. And it's very simple to understand. You all our students have done coding before, and many of you have already done Arduino coding, so this is nothing new to you. You can see the Arduino software, which we call Sketch over here, and there are main three areas in the sketch. In a sketch, you have the declaration section where we put the variables like the LED pin number or something like that. Then we have the void setup function. So the void setup runs when you turn on the Arduino the first time, or you load the program the first time. This whatever is inside the void setup will run. So I'll explain what is inside here later. Then we have the void loop. So the void loop, you know what a loop is, right? Loop is something that is, going on and on and on and never ending, right? So the void loop runs continuously without stopping forever and ever. So whatever is inside that will keep on repeating, right? And I'll show you how we can take this to use. I'll show you this basic structure of a program, and I'll explain more when we actually write it in the Arduino sketch. So we have the first command, or the first line, which is int LED equals 13. Now what is this particular 13? Going back to the Arduino, you can see that these pins have a number, right? So the digital pins starting from 1 to 2, 3, 4, 5, 6, 7, and then over here we have 8, 9, 10, 11, 12, 13. So these are all different pins, and this letter or the number is the pin number. And here we have the ground pin. Ground, generally we connect the negative terminal of electronic component, and on over this side it's a little bit unclear. We have another ground, and we have a positive 5-volt electric supply, which we can take out when we are doing projects. So here what we actually do is we say, now I said these pins can be both input and output. So we need to declare if we are taking an output from this pin, or we are giving an input electric signal. For a LED, what do we generally need? Do we need to input something or output? Alright, we need to output an electric signal and make it work, right? So that's why we have declared this LED as an output pin. And so that's what we are doing. So this LED word over here, it's called a variable. A variable it's nothing hard to understand. It just contains a value. You use that to contain some kind of value in a program. Instead of saying 13 all over this place, we can just say LED, which is easier to remember. So void setup, pin mode, LED, output. We brand this as an output pin. And you can see this is called a function in programming. So we start it with the opening curly bracket and close it with the of course the closing curly bracket, and the command names the function names have something called the camel notation. It's humps like this. So first word is starting with simple, second word and so forth will always start with a capital letter. We call it camel notation if you don't know about it. And we finish every line with a semicolon, so that the program knows that the program has come to the end of a particular command. Then we go to the void loop, which I said will repeat on and on until the board is turned off. So first I said digital write. So we are outputting a signal. So digital write, we are outputting or writing a digital signal to which pin? The LED pin, which is pin number 13. And we are outputting a high signal. So what happens? The LED turns on, exactly. And this delay command can halt the program. So what is inside is in microseconds. So 1000 microseconds is equivalent to 1 second, right? So that's what we do. We delay for 1 second, and then after that we do a digital write to the same pin, which is the LED pin, and what we write is a low signal. So what happens when we output a low signal? Yeah, the LED turns off, and then we wait for 1 second. So basically, if you put this into an Arduino, what kind of program do we get if we have a LED? It will turn on, stay 1 second, turn off, stay 1 second, turn on, 1 second, stay off, stay 1 second. So it will keep on working on and on because it's inside the void loop. So hope you can all understand this structure. If you can understand this structure and know what every single line of this does, it's going to be very easy for you in your Arduino journey. So again, just to summarize some of the functions, we have the pin mode, where the first parameter, we call this parameters. First parameter is the pin number, second parameter is the mode. So it's pin mode 1 comma output or 1 comma input. Then we have something called the digital read, so which we'll also learn about when we put a push button to our program. So digital read is where we learn how to or rather we use that to input a particular electronic signal on into the Arduino. So as I said, the pins can be used for both input and output. So in this case, if you put pin number 13 or whatever it is into digital read, we can get input from this particular pin. And basically we are getting either a low or high signal. Digital write, we learnt about it. Parameters are the pin number and the value, again high or low. Analog read, if you have an analog component like a particular sensor, we can read the value, analog value like this, and it will input from 0 to 100. You can see, as I said before, digital is either high, low or high. Analog can be from 0 to 1023. Analog write, very similar to that. And then of course the delay, as I said, the parameter is time in milliseconds. You can go to this page if you want to find out more syntax. So you can pause the video and write this down, this particular link. You can go ahead and find out more syntax. This word syntax, yes, syntax is the different ways of writing the different commands. Alright, so now to teach you about this new platform we are going to be using. So if you have an Arduino board, go ahead, take the Arduino board out. You need some jump wires, a breadboard, a couple of LEDs and a push button. If you already have it, you can take it, or if you don't have these components, do not worry, because we are going to, because Tinkercad already has all these components readily available. And we are going to get started now. So Tinkercad is a project by Autodesk, or rather the same guys who created AutoCAD. Tinkercad is the education version. So you can do more things with Tinkercad, and I'll show you as we do. So let's get started. I want all of you to go to this particular website, www.tinkercad.com. So I have already gone into that website over here, tinkercad.com. So what you need to do now is you need to create a profile for yourself. So what we're going to do is we're going to click on join now, and you can skip this particular option and create a personal account. If you already have a Google account, you can directly sign in with the Google account. So I'm going to click on sign in with Google. And I have two email accounts that I use, so I will select this one, and I need to enter my password. Oops, wrong password. Alright, so when I enter my password, I will go into the login screen and directly into Tinkercad. So sign in to Tinkercad using your email address, using a Gmail. If you don't have a Gmail, you can use your parents' one, or you can create a Gmail. It's very easy. So once you are here, so Tinkercad has few parts which is important. So the first part is the 3D designing part, which some of you may have done before, but if you haven't, it's something that is very fun to look at. This is not what we are going to do in the workshop, so I'm not going to go into detail with this, but I'll just show you what you can do with Tinkercad, since you need to know. So Tinkercad is mainly used for 3D modeling. So you can build cool 3D models using Tinkercad. You know, you can change the sizes, right? You can add demo components like this, right? And you can merge these components together, change the colors. You know, you can do so many fun things with Tinkercad. which is the 3D design part of it, but we are not going to be using that. That is for you to play around with when you're at home, practice on 3D modeling, because for 3D printing we use this software. We model the whatever we want to print using Tinkercad, and then we upload it to the 3D printer to print. So if you have any plans of doing 3D printing, we'll do a future workshop on 3D printing as well. But anyway, this is a platform for you to really try out. It's a very fun platform. So we'll go back to tinkercad.com, the dashboard, because we are going to be learning about this circuits section. So using this circuit section, we can create various circuits, not only Arduino, any type of circuits, which is very easy and very fun. So we'll click on create new circuit over here, and we'll go into the circuit screen. Alright, now you can see that there are various different components over here like this, even an Arduino Uno, everything is here, right? I'm just going to change the size a little bit. You can see the different type of components. So we'll try it out. We can put an LED like this, drag and drop it. You can change the color to any color that you like. Maybe let's make it orange. And then I can put a 1.5 volt battery like this. And here's my negative, which I'll connect to the negative. Oops. Oops, I think I made a mistake. So we have the cathode that will go into the negative, the anode will go into the positive, and we click on start simulation, and you can see the LEDs lighting up. So just to show you what I did, I'll delete these two for you again. Now the LED has a positive and a negative, right? So the cathode is the negative and the anode is the positive. So anode you can click on this anode and drag the wire and put to the positive terminal of the battery, and generally positive we have a red wire. Cathode will do the same thing, click on it and put it to the negative terminal of the battery, and we can generally negative is black. And after we do the connection, we can click on start simulation, and you can see that the LED has turned on. So we can try it with a different color, red color for example, start simulation, you can see LED turns on. Now if you want to modify this with let's say a switch, you can do that. Put a switch, we'll take this wire, connect it over here, and we'll take this terminal and connect it over here. Start the simulation, turn it on, turn it off, turn it on, turn it off. Can you see how cool this is? Yeah. So you can create different sort of electronic projects with this Tinkercad electronics or circuit section, which is very fun. Just try it out. Yeah, they even have the ultrasonic sensors and PIR sensors, multimeters, photoresistors, motors, everything is there. It's very fun. Even push buttons. So now we are going to play around with the Arduino. So we'll just delete this, right? Just going to delete. Just click on the component and click on delete. Right. So what we're going to do is we're going to go into over here, and we're going to insert an Arduino like that. Oops, I entered two Arduinos. Right. So what we're going to do now is we're going to connect an LED to the Arduino, right? So I'm going to take the red LED like this, and I'm going to put the negative to the ground pin and the positive to pin number 13, as you can see over here. Hope you can see that the negative goes to the ground, positive goes to the 13th pin, right? That's all I'm going to do, and we are going to start coding. It's very simple, right? So what I'm going to do is I'm going to go to the code section over here, and Did you see what I did? I clicked on code, and you can either code it in Scratch, but we are not going to do that. We are going to click on these blocks. We are going to click on text, click on continue, and here you have the code. So okay, code is already written, but I'll delete it and I'll show you how to write it. Right? So we are going to start with a variable as we looked at before. Int LED pin equals, what is the pin that we put our LED to? It's pin number 13, right? Yeah, pin 13. And to make it easier to you, what I'll do is I'll just take the LED out and I'll connect it using wires. So cathode negative will go to the ground. Generally we use it in black color. Anode will put it to, let's say, pin number 8, right? Which is, let's say, any color, that doesn't matter. Oops. And let's go back to the code now, right? So LED pin is now changed, it's 8. Put it as 8. Finish off with a semicolon. And next what you're going to do is you're going to write the void setup. You have 2 brackets and 2 curly brackets. Put a space in between. Now what I'm going to do is I'm going to declare this LED pin or pin number 8 as an output pin. So we use the command pin mode. The parameters are the pin number, which is LED pin, comma output. Can you all understand this? Yes, good. Then we'll go into the void loop, where what we're going to do is we're going to use digital write, and the LED pin we are going to write a, what is it, a high signal. What is this going to do? It's going to turn the LED on, and we're going to wait 1 second, so 1000 milliseconds, or let's wait 2 seconds, so it's 2000 milliseconds, or half a second, which is 500 milliseconds. And I'm going to switch off the LED. So what do you use to switch off the LED? That's right, we use digital write, same thing, but we put LED pin comma low, and I'm going to put another delay, half a second, because if I don't put a delay, what happens? If I don't put a delay over here, what happens? This will not stay on, it will directly go ahead and turn on again, right? Because after this statement, after you reach this point, it will go back to the top. That's why we call it loop. So I'm going to now click on start simulation. Oh, there's an error. Oh, great, that's good that happened, so I can show you. So you can see that the software will show you errors if you have any program errors that you have. So can you all figure out what the error I have is? Oh, find it. Oh, I know you can find it. Yes, it's very simple. We are missing a semicolon over here. So we'll start the simulation. Oh, and you can see what's happening, right? LED is turning on, off, on, off, on, off. Isn't that pretty cool? So you want to try it with another LED? Yeah, right, good. So before we try that, I'm going to teach you one more thing, which is about the breadboard. I'm pretty sure all of you know how to already use the breadboard. So I'm going to drag and drop a breadboard like this, right? And you know this rail is for the positive and this rail is for the negative. So the negative I'm going to take like this, and I'm going to, or rather I will use the other side. Negative, we go. Can you see when I'm clicking it like this, I can nicely arrange the wire without just dragging it. And this is going to be black because it's a negative, and the positive rail I will go ahead and plug it to the 5 volts, and this can be red. So now I have given the power supply to the breadboard, right? Now I can drop the breadboard somewhere over here. And now what I'm going to do is, instead of connecting the LED to the Arduino board directly, I'm going to fix the breadboard or the LEDs through the breadboard like this. So you know that in a breadboard these lines are connected and these railings are connected vertically, or in this case it's horizontally and this is vertically. So So you can see they're connected like that. So this line is all the same. So what I'm going to do is, since this is the negative, I'm going to click over here and I'm going to plug it to the negative or the ground of the Arduino board, which is connected to this particular railing. And what I'll do is I'm going to add the black color wire, and this particular positive I can now go ahead and connect it to pin number, which is the pin that we use, pin 8, right? Yeah, pin number 8, whatever color. Now shall we try out our code and see if it works? Start simulation. Oh, it works perfectly, as you can see. So the breadboard is very simple to understand. So now, as we said, we're going to put another LED because the traffic light has 3 lights, right? So I'll put another LED over here and another LED over here. So in the traffic light, we have a red one followed by an orange one, or maybe a yellow one rather, and then we have the, yeah, it's actually orange, right, not yellow. Then we have the green one. So this is what a traffic light looks like. Am I correct? So now let's connect the other LEDs as well. Alright, so now let's connect the other LEDs as well. So both the orange LED as well as the green LED needs to be connected to the negative. So I will connect it to this particular negative rail, black wires, and the positives I will actually connect to different pins now. So maybe the orange one can go to pin number 9, and our green one can go to pin number 10. Alright, so we'll have different colors also. Maybe red, no, pink. Yeah. So let's code it now. We go to the coding section, and what I'm going to do now is we need to put the other 2 LEDs also now. So we'll go ahead and declare a variable to hold the pin value of the other pins or the other LEDs also. But now what I'm going to do is I'm going to change the variable names called red, orange and green. So red will be pin number 8, orange will be pin number 9, and green pin number 10. Alright, and I will have to set up the pin mode of all the 3 pins, right? So I'm going to just copy paste this like that, 8, 9 and 10. And now to turn everything on, to blink the entire traffic light off and on, what I will do is I will say 8 high, at the same time other 2 also 9 and 10 also high, and even the low one I'll put 8 will be low, that is to switch off the red LED. Oops, I did a big mistake, not a big mistake, but I forgot to use the variables. You can just use the variables, right? That's just a big mistake. Red, orange, there's no problem with the code, but defeats the purpose of a variable. We can easily say red, then we don't have to remember 8, 9 and 10 like that. Instead of saying 8, 9, 10, we can say red, orange and green, because we have already set up the variables here. And here also we can say red, low, orange, low and green, low. Shall we try it out now? Alright, so let's start the simulation, and we can see, very cool, all the 3 red, orange and green LEDs are blinking on and off, right? So now let's do a small, now this is all about understanding the structure of a program. You can comment out code by using this slash and a star. So all the code below it will be commented until you put another star and a dash. So this whatever is inside a comment will not be run. So we are putting this comment so that our code we don't have to remove, but this code will be skipped because of this comment. So now let's code the traffic light. So initially what happens in the traffic light, the red will be on, right? So we are going to say digital write red high, and the red will stay on, let's say, for 5 seconds. Delay 5000, that's 5 seconds. And then what happens is it will go into the green orange one, and the red will have to switch off, right? Digital, you have seen how traffic light works now. Red, low, and at the same time when we switch off it, we need to turn on the orange LED. Okay, so with the orange turning on, it will stay on for a little bit of time, like half a second, right? And just like that it will switch off, the orange will switch off, low, and the green, as it's switching off, will turn on, right? Digital right green high. And what happens, the green will stay on for, let's say, 5 seconds, so delay 5000, and then it will go back to red. So how does it go back to red? So after waiting for 5 seconds, green will switch off, low, and when it switches on, what happens, our orange will turn on, and we can keep it for about half a second, so 500 milliseconds, and with that digital right orange will switch off and our red will switch on. So this is nothing hard, this is the way that a traffic light works. So we'll run it and I'll show it to you, then you can understand it more easily. So when we start the simulation, we can see, oh, there's a problem, we missed a semicolon here. Thanks to Arduino, you can easily find a bug or any errors. So red is going to stay on for 1, 2, 3, 4, 5, and from yellow it went to green, 2, 3, 4, 5 to yellow, and then to red, 2, 3, 4, 5 to orange, to green, 2, 3, 4, 5 to orange, to red. Can you see? So the code is working currently. So this is an example of an automatic or rather normal traffic light. How do we make it operated from a button so that a policeman can change it whenever he wants, right? So it will be red when you click, it will be green. How do we do that? So to do that, we need what we call a push button. So we'll learn how to put the push button now. Switch off the code and put a push button like this. And what I'm going to do is, I'm going to add a resistor, right? I'm going to take a resistor and I'm going to add the resistor to this particular pin, like that. Can you all see that? Great. So once you add the resistor over there, what we're going to do is we are going to do the connections. So to do the connections, the resistor line will go directly to the negative, like this, and the other point, which is this one, terminal 2A, will go to the positive. And so we'll change the colors, red, okay, black, and this one will go to our Arduino, to whatever the pin that we choose to input our push button to. So we will input it to maybe pin number 4, yeah, just like that. You can change the color to whatever we like. There you go. So you can see that connection, right? The push button connection, we have done it. So now how do we code the push button? It's very simple. So I will show you. Go to the code part, and we're going to put another variable for the push button called the int push button, and we know the pin for the push button is pin number, what is it, 4. That's right. Now the push button pin is not an output pin. What is it? It is a input pin. So we are going to say pin mode push button. So you can see I'm writing it in camel notation, and I will say input. Now it's an input pin. Now what I'm going to do is I'm going to remove this code, we don't need it, right? I'm just going to go down like this. We will not need this code also because we're going to rewrite a new program. So first I'm going to, when the program starts to run, I'm going to keep the LED on, the red LED on, and it will stay on. And what happens is, I'm going to take, when the policeman presses the button, he can change or make the traffic light to go green and then come back to red. So we need to make sure to get the value of whether the button is pressed or not. So how do we do that? We use a command called digital read, which we talked about before. So I'm going to add another variable called int button state, right? And I'm going to keep it as 0. So button state will hold the value of the electric signal, whether it's high or low. So I'm going to say button state is equal to digital read from which pin? Push button pin. And what will happen is, if you press on the button, digital read will write a high value to button state. If you don't press it, it will write a low value. So with a simple if condition, this is how you write if condition. If you don't know, very simple. We are going to check if button state is equal to high, right? So if the button state is equal to high, we can simply do something like this. So now the red is on. So what we are going to do is, as soon as you click the push button, we are going to turn the red off. And we are going to do the same thing over here, which I'm going to copy and paste because we don't need to write it again. We're going to actually cut it and then paste it. So we need to remove this part off, because what we are going to do is, right, what you're going to do is, when you press the button, we're going to turn the red off, go to the orange, turn it off, turn the green on, and then come back to red. Just the same code that we wrote before. But this will only happen when you press on the button, not automatically like before. So shall we test it out? So we're going to click on start simulation. Alright, now it's red. As you can see, it's not becoming green. So the policeman now can manually press on the button, and what happens? It will become green and stay for 5 seconds and go back to red. And that's it. It will not continue until you press the button. So let's try it again. We're going to press it. 1, 2, 3, 4, 5. Go back. Just like that. Press it again. Go back to green and go back to red. So that actually comes to the end of our lesson. It's a very simple project that we did, but we learned many things. We learned in detail about Arduino, about the different commands that we use, the different functions and what they do, and above all, we also learned about inputs and outputs, how to use the Arduino for inputs and outputs over here. And most importantly, we learned about the new Tinkercad platform, which is a really great platform if you want to do a lot of Arduino projects online without using the Arduino board. So it's a great tool for you to use, guys. So you can simply save. So Tinkercad gives these funny names to your projects. You can simply put any name you like, Arduino traffic light, like that. Maybe, yeah, there you go, it's saved. And when you go to your dashboard, you will be able to see all your projects. So you can create, it's loading, see the project is shown. You can reopen it by clicking on Tinker So you can create some fun projects from this Tinkercad. So hope you all enjoyed today's lesson. So once again, we are sorry that the live stream didn't work out today, but we'll make sure that we'll get it sorted out and bring you some more fun sessions like this, so that you spend your time at home productively. And I wish we can start the classes soon after all this trouble is finished. So I wish you all stay at home very safe, and see you again in another video where we'll build another exciting thing. So until then, bye bye.